Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And I'm Emily. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Nicely done. So, where do you attend school?
Stockdale Elementary.
And what grade are you in?
4th grade.
You go to school longer now than you used to, or is it the same amount of time?
Same amount of time.
Same amount of time. So, yeah, I think they read, it's like everybody kind of goes the same amount of time now. So, what do you like most about 4th grade? Because you've been there for a couple of months now, right? About a month or so?
I like now we learn cursive in 4th grade.
Oh, you like doing cursive? Mm-hmm. Good. Well, that's going to be a handy skill to have because you're going to have to be signing your name to a lot of documents and stuff when you get a little bit older. So, what is it that you like about cursive?
I like it's fun to write with.
Okay. And you're getting pretty good at it, you think?
Yeah.
All right. So is there anything you miss about 3rd grade?
In 3rd grade, we did a lot of art projects.
You haven't done so many in 4th grade yet?
No.
Well,
we haven't done any.
You haven't done any. Well, I'm sure you will start doing some art projects.
Yeah.
And the reason is because now you're getting into some more subjects that you're going to have to spend a little more time on sometimes. So you kind of spread it out a little bit, and I'm sure you're going to be doing some art soon, because I think almost every school has an art instructor, right?
Yeah.
So you do get to go to see the art person every once in a while, right?
Yeah.
But you would like to go every day, I take it?
Yeah.
Okay, why not, right? All right. Hey, you going to help me out with today's social media problem of the day? Mm-hmm. All right, let's take a look at it together. It's right up here. All right, so it says problem of the day. It says find the product. Now, when we see product, do you know what that means?
Yes, it's the answer to a multiplication problem.
Good, right? So obviously we can see that we're going to multiply 8 times 104. So when you look at that, because we're not going to write it down and work it out, we're going to see if we can do this in our head.
Yeah.
So how do you want to approach that problem?
Well, if you multiply 8 times 4, it's 32. So the end of the multiplication problem has to end in a 2.
That's a good thought, right?
Yes.
So it could be B or C, because those both end in 2.
Yeah.
So how do you know which one it's going to be?
Well, the next number is 8 times 0. So
Okay, well, what's 8 times 4, first of all?
8 times 4 is 32.
Okay. Do we see a 32 up there at all?
No. Yes.
Okay, at the end of C, right?
Yeah.
Okay, and then if we took this 4 and just made it a 0, what would it be? 8 times?
8 times 0.
If we took the 4 and made that a 0, it would be 8 times 1, 0, 0. 8 times?
100.
100. And what's 8 times 100?
8 times 100 is 800.
800, right? Does that make sense?
Yeah.
Okay, so if you look at the problem, we have 8 times the 1 is in what place value?
The 100.
It's in the hundreds, so that's 100. Okay, there's no value in the tens, it's just a 0, right? We're using it as a placeholder basically right now. And the 4 is in the ones, right? So it's just 8 times 4 is 32, right? And 8 times 0 is?
800. So it has to be 832.
Okay, so 8 times 100 is 800, right? And there's no tens. So we just have 800 and we have 32 to add together. So what will the answer be?
832.
You're feeling good about that? Even though B has a 2 at the end of it? So whoever showed you that little thing about the number has to end in a 2, that's a pretty slick thing to know. But sometimes there might be more than one answer with a 2 at the end of it, right? All right, so let's take a look and see if indeed you are correct. There you go. C is correct. First problem well done. Nicely done right there. 636-4357 is that phone number. We do have phone tutors available Tuesdays and Wednesdays between 3:30 and 5:30. Time now for today's Math in the News. And in studio with us, we have Nikki. How are you today?
I'm good. How are you doing?
I'm excellent. I was able to go to the fair over the weekend, and we were going through the crafts building, and we saw some people there with quilts. And immediately I was like, oh, this is something that's going to be able to apply some math to it.
Yes.
And you are like a master quilter, correct?
I've been quilting for almost 40 years.
Yeah, a long time, right? So you started even before you started school, correct?
Yes.
Okay. So tell us a little bit about the math that you're thinking about when you are quilting.
So when I'm quilting, I use whole numbers, and it's pretty basic math with addition and subtraction. I'm going to, if I want to create a quilt, I'll take the main numbers of the blocks, like this is an 8x8 block, and I want to add
Okay, so we're going to hold this up a little bit. So
I want to
some of the
add some
cameras can
strips
see
to it, then I need to know the measurements of these strips so I can add them together. And then the most important part whenever you're quilting is that you always have a seam that they get sewn together with. Most of the time it's a 1/4 inch, so you're constantly adding 1/4 inches, that decimal, and adding whole numbers together. If you're good at math, you can actually create your own quilt right at home.
Okay, and a lot of it is addition.
It is.
That you're doing. So it's not like calculus or anything like that. You just need to know some basic things.
Just the basic 2nd grade math is all you need.
Okay. Now, how do you come up with the designs? Is that because that's a lot of just the creativity on what you're coming up with as far as the designs?
It is 100% creativity. You can buy a pattern that someone's already created, or you can create your own. I look at my pattern, I look at my fabric, decide how I want my fabric to look, lay out, and then I go to a piece of graph paper and start drawing out my squares. One square on graph paper is 1 inch on a quilt, and off I go, and it kind of creates itself.
So you just come up with the idea, and then you go ahead and start, and then it just kind of takes a life of its own after
Exactly.
that, right? And how did you get into quilting?
I got into it through my family. My great-grandmother and I spent many years quilting together from the time I was 3, barely using a hoop and a needle, and then going into more complex geometry with some pretty fancy quilts as I got better at it.
And great-grandmother was pretty comfortable with you using a needle at that young age too, right?
She was.
She was right there with you though.
She
and
was.
helping
You know, you
along.
get pricked a little bit every once in a while, but
Yeah, it's just a little.
it's not
bit, right?
bad.
So if somebody wanted to get into quilting, right? They're like, hey, you know what? I found that, you know, this could be relaxing. I want to do something creative, and this might be something I might be able to do. How does somebody start?
There's always YouTube, which is a fantastic resource for pretty much anything. But if you want to get a hold of somebody locally, I love the Tehachapi Quilters Guild. They're fabulous. If you want to start right now and you're here during the fair, then go on down to Building 4 to the needlework section in the back, and you will meet all kinds of quilters who have many more years experience than I do.
And there, when you're there, they have a lot of different quilts on display.
They do. They
And-
have everything from piece quilts like this one to art quilts where it's more of a paint by numbers.
Okay, so piece quilt, you said this is a piece quilt,
Mm-hmm.
as opposed to,
An art quilt. So piece quilts are strips or squares of fabric, and then you can get it more complex with art quilts, which is more like paint by numbers, and you're actually taking different shapes and bringing them together. And that takes much more complex math, but it is still mathematical
right, and
with circles and geometry.
kind of reminds me of tessellations and reflections and rotations and things like that, a little bit higher level. Not higher, but a little geometric influence in that also.
Yes, exactly.
Well, good. Well, Nikki, we certainly do appreciate you taking some time to come down and share with us this. And you are once again in Building 4?
Building 4.
At the Kern County
Arts and
Fairgrounds.
Needleworks.
Okay, so you'll be able to, you're visiting from San Diego.
I am. I come down, the Kern County Fair is fabulous, and I love the women who quilt down here, so I come down here to visit with them every year.
Well, good. Well, if you have an opportunity, head on out to the county fair and check out Nikki and the rest of the quilters in Building 4. We'll be back with more right after this. Well, our mathematician of the day is John Napier, a Scottish mathematician, and he didn't get schooled the way a lot of us get schooled. He stayed at home until he was 13, simply studying things around the house and being raised by his parents and just learning that way with no formal schooling. As he got a little bit older, there were some thieves taking things out of the barn, and they tried to devise a way to figure out who was taking all of these supplies out of the barn. Well, what he did is he came up with a way to catch a thief, and what he did is he put some black oil on the back of a rooster, but he didn't tell anybody. He simply said, "I've got a magic rooster in the barn, and it will let us know who the thief is. We simply need you to go in by yourself, wipe the back of the rooster, and then come out." So he had these 4 suspects, I guess you could call them, 4 people that worked at the barn. All of them came out. One guy's hand was clean because he didn't wipe the hand on the back of the rooster because he knew something might be happening if he did that. The other 3 came out with the black oil on their hands. He came out with a clean hand, therefore they knew he was the thief, and that's how he did it. So just a little bit of ingenuity right there with John Napier. He's famous for Napier's rods, which were 10 strips of ivory or wood, and small enough to carry around like we would a calculator right now. We're going to take a look right now at Napier's rods, and this is the way they would be set up. So each one of these, all 10 of these, would be separate pieces of ivory or wood, and the numbers would be on them like this. Then he had one which was an index. So what we're going to do is we're going to take 836 and we're going to multiply that by 7. So we can see we're going to start with 8. We need the 3, and we need the 6. So there's our 836. We're going to multiply it by 7, which we're going to use on our index. So simply we're going to meet at the intersections. So the 7 we know is going to go all the way across. The first one is 8. So we can see that there's a 5 and a 6 here. So we'll put the 5 and the 6. The next one, the 3 for the 30, is 2 and 1. Next, we have the 6. So we have 836. We come across from the 7. We can see that we've got a 4 and a 2. So now, simply what we're going to do, similar to the lattice method that a lot of students are familiar with, we're just going to add the numbers going across. Instead of multiplying in our head, we're simply going to add. So we see that going diagonally, we have a 2. We take these, the 4 plus the 1 makes a 5. The 2 and the 6 makes an 8, and then we have a 5. So 836 times 7 is 5,852. Napier's rod's the first pocket calculator for today's mathematician.
Did you know that the modern multiplication sign comes from a British mathematician? It replaced the dot between 2 numbers to symbolize multiplication of money I don't have. Now you know.
Thanks for landing in that little now you know tidbit right there. And you are actually multiplying in 4th grade right now, correct?
Yes.
So you're doing a little bit of multiplication. How do you feel? You feel comfortable with that?
Yes.
Good. I'm glad you're comfortable with that because I'm going to give you something else to do. Good with that?
Yep.
Head on over to the board, young lady. Have you ever heard of a fellow called Fibonacci?
No.
Oh, today's your big day, sister. All right. So Scott, do me a favor and just write up on the board 1, 1, 2, 3, 5. All right, that's it. Yep, all right. So, Emily, I would like you to discuss with Scott anything that you see up there, any patterns that you notice, and just talk to him about what you notice about those numbers up there.
I see that they're all odd numbers.
Mm-hmm. Except for which one?
Except for the 2.
There you go. So they are all odd except for the 2. Good. That's a good place to start. What else?
2 plus 3 equals 5.
Ah, so we have a little bit of a pattern there, right? You say plus here.
And what is your favorite number? The reason we're doing this is because what's your favorite number?
8.
Keep going.
Look at that.
5.
So let's see here. You said 2 plus 3 is 5. Does that same pattern work anywhere else in this sequence? No. Like what if we just started at the very beginning? What's 1 plus 1?
2.
Hey, that worked out pretty well. What about 1 plus 2? What's that?
3.
Ah, so it did work. So that looks a pretty good pattern that we're looking at there, right? So if you had to predict what the very next number is, what do you think it might be if you followed the same pattern? So 1 plus 1 is 2, and then 1 plus 2 is 3. 2 plus 3 is 5. Which number are you going to add this time?
I'm gonna add 3 plus 5.
There you go.
which
What's
is
3 plus 5?
8.
8. I like it. Now, if you had to predict the next number, what might it be?
13.
That's it. There you go. So this is a sequence where you always add the 2 previous numbers to get the following number. And if you wanted to get the 200th number way out there, might take a little while, but that's how you do it, right? You keep adding them up. Yeah, Fibonacci sequence. I like it.
Right, that's the Fibonacci sequence, right? And when you said that your favorite number was 8, I was like, oh, perfect opportunity to bring this up. Because in all of mathematics, there's always a pattern. All you have to do is see if you can find the pattern. Just like when we were looking at Napier's rods just a moment ago, how he was multiplying with those rods, right? And you're like, oh, that's pretty cool how to do that, right?
Yeah.
He found a pattern, made those rods, and made the first pocket calculator, right? Carrying around 10 rods, and you just put them in the correct order. But the whole thing is finding a pattern. And a lot of times there's multiple ways to do a math problem. Does that sound like something that would be all right to do?
Yeah.
Good. Well, you know what? For taking a look at Fibonacci sequence and kind of seeing that pattern right there and figuring out with Scott, you've got yourself a couple of tickets to the Kern County Fair. So congratulations on that. Hopefully you have an opportunity to go and check out some stuff. And who knows, maybe you go to Building 4, check out Nikki and some of the other quilters, and you can find out a little bit more about that. And we'll be back with more. Oh, you know what? Actually, right now, someplace we have brand new right now is the Steam Yard. And we're going to be heading over there because we're going to be doing some science activities and art activities. Right now, we're going to go check out one of the science challenges with Devin. We're heading over to the Steam Yard.
Welcome to this week's Steam Yard Showdown. Today, teams of 5th grade students compete to solve a hands-on engineering challenge with limited time and materials. They're racing the clock to see which team can score the most points towards the championship. Now here's your host, Devin Rossiter at the Steam Yard.
And we're here. Thank you so much. My name is Devin. This is Jamie. We are here. It is the kickoff of the Steam Yard Showdown, live from downtown Bakersfield. We have 4 teams of 3 students each putting together some really amazing projects and devices that meet certain challenges. And over the course of the next few editions of this, they'll be earning points en route to this. Our Steam Yard Stanley here, the championship trophy that'll go to one of our 4 teams. Jamie, tell us a little bit about the Steam Yard Showdown and what our students are working on today.
So today's challenge has to do with a winch. And so with our sports theme, we also wanted to incorporate some STEAM with a winch and talk about different types of sports as well that you would need a winch with. Yeah.
So in order to build this winch, they have some constraints, they have some materials. Tell us a little bit of what they're going to be using to build their winch and what their goal is.
Okay, so today we want to make sure that our students are using cardboard tubes, and they can be various sizes. We also have a spool. They get 1 spool, and then they will get 4. They can get up to 4 dowels. They don't have to use all of them, but they will use them. And then they'll get a roll of tape, and then they also have string. They have 24 inches of string.
So as they build their winch, their devices, they've had a chance to sketch it out. What is the goal?
So the goal is the students are going to try with their bucket lift 4 pencils at least 3 inches. So we're really excited, and we're going to see if they can actually do it.
There are a couple of rounds and iterations that they're going to be building on here. The goal for the first round is 4 pencils. They lift the bucket with the 4 pencils off the ground 3 inches, and if they're able to do so, they'll earn 40 points. And we'll keep track of the scores after each iteration with a bonus opportunity towards the end as we get to our final segment here. But for now, let's go ahead and meet some of our teams and see where they are on the journey.
Right.
Let's start things off and introduce you to our Green Knights. Let's say hello to the Knights with Emmanuel, Finley, and Trevor. Friends, we are right in the thick of this. Tell us a little bit about the process. Emmanuel, walk us through what you're building right here.
So we're trying to build a crane, a winch that requires us to put it it's still kind of a little up in the air, and we're trying to figure out what parts work, what parts not. And so far we're on the base, and we figure out the mechanism to do this.
You've been able to wind the string up around the spool to use that as kind of a leverage piece, and even though you have it wrapped around, it still seems to kind of pull through pretty nicely one end to the other, regardless of which way you're pulling
We're
up.
going to tape this part, the string right here, so that way the string doesn't mess up.
So how closely is your build so far tied in with some of the designs that you sketched out early on?
So we scratched out the triangle design, and we're trying to just go for a straight.
So instead of having kind of a keystone from the top, we're using just a straight bar to help out with our crank at the start.
So it's gonna not yet. So we're gonna go like that, and then it's gonna like somehow spin. It's gonna be over here. I'm just doing this. It's gonna be this. The bucket will be lifted like this, and you spin that, and it, like he said, the force of gravity will go like that, and it will pull the string up. And it will also pull the bucket.
We'll check in with the Knights later on for our first iteration. Let's move on over to the Purple Comets with Jade, Alani, and Cypress. Cypress, tell us a little bit about where your team is in the process right now.
We're gonna figure out how to put this there so it can tie on to this and lift it up.
So we're looking at using the spool through the dowel. There's plenty of tape there with the string, but we're now faced with the challenge of how do we attach it to the top piece here so that we can crank it up and connect it to the bucket. What are some of the conversations you've had about that process so far?
So we were thinking to possibly like puncture a hole in here so that when we put this in, it doesn't like start wandering around like this.
And the string will go through the hole.
Oh, and you've already punctured through. Okay, so we'll see if that strategy pays off at the first iteration. Let's move on over to our Yellow Lightning here with Adrian, Bilawal, and Haris. Haris, tell us a little bit about where we are on our journey.
We're making the hole so we can put this stick, and we'll attach the string, and that string's attached to the bucket, so we can make a lever, and then we can spin it.
So you're going through that similar thought process of puncturing through the cardboard tubes so that you have something to attach your dowel to. And then I see that we're starting to tie in the string to the bucket. Adrian, where are we with the spool?
So far, we've thought about inserting it like this and putting a crank.
So you'll build the crank using another dowel to give you a little bit more leverage as you turn it. We'll see how that turns out for you. Finally, let's check in with the Blue Sharks. We've got Vance, Elena, and Sashwar. Sashwar, where are we on this journey here?
So right now we're making, right now we have 2 tubes, which is the sides. So what we need is actually supposed to spin, lifting the bucket 3 inches in the air.
So as you rotate that, and it looks like you're going to position the bucket kind of in front of the base or inside of the base here. Okay, so have you been able to figure out a way to connect this spool? So it feels like it's pretty sturdy right there, so that when you turn it, it's a little loose right now. So are we working on a way to make sure that those are connected so that the turn of the dowel connects with the spool?
I mean, we could attach tape inside to make it stick with the skewer and make it spin.
We'll see how it turns out for you. All 4 teams right in the thick of it. When we come back, we're going to test out their devices on our first iteration. Can they get those buckets with the pencils 3 inches off the ground? We'll find out in a moment.
All right, thanks to Devin. Steam Yard, and those kids are going along very well, don't you think, right now? Yep. They got a lot of good ideas and stuff like that, and they're working pretty hard, so we'll see how this all works. We'll be back with more right after this.
Hi, I'm Mary Lou, and welcome to another session of the California Mathematics Framework. Today, we're continuing on with Chapter 3, Number Sense, and we're discussing how to understand multiplication. Students in kindergarten through 2nd grade use additive thinking to help them make sense of numbers. Sometimes they're using repeated addition or skip counting to help them move through. Here we have 4 groups of 3, and students are using repeated addition of 3 to help them get to 12. Or we're using a number line to help us skip count by 3s, 3, 6, 9, 12. When students transition into third grade, they're taking additive thinking and they're moving it into multiplicative reasoning, where we're now seeing 4 groups of 3, which we now know is 4 times 3, which is 12. So we're being able to look at larger numbers. I have a friend with me today. Would you like to introduce yourself?
My name is Sharia Vidula.
So, can you help me with multiplication?
Yes.
Okay, so I have this problem of 8 groups of 7. I know you know this answer, boom, right, in your brain.
Yeah.
But can you show me a multiplicative way of how to think about this? And can you do it right here for me, right underneath, okay? How do you think of 8 groups of 7?
It would just be adding 8 7 times.
Can you show me that?
So it would be 8 plus 8 plus 8 plus 8 plus 8 plus 8 plus 8.
And which equals?
56.
Okay, so you kind of use that repeated addition to help you know that this is 56, right? What if I had this problem? 80 times 7. What's 80 times 7?
Well, since it's just a 0 added, you just add a 0 to, well, this, since it's the same answer.
So what you're telling me is that you understand what 8 times 7 is, right? So now thinking of this as tens, this is 80 groups of 7?
Yes.
Yes? So here we have 8 groups of 7, but now we have 80 groups of 7. And what is 80 groups of 7?
560.
Can you write that under here for me? What is that? It's 560. Okay. What if I had 79 times 7? Is there anything here that can help you solve 79 times 7?
No.
Think about that. Is there something that we've done here and here that can help you quickly solve that?
Well, 79 is just 1 less than 80.
Okay.
And since you're multiplying by 7 still, you just take a 7 away from this answer.
So how do you do that? If you're taking a 7 away from that, what do you
So you
do?
just take a 7 away from this.
Okay.
Which would be 553.
Oh, 553. So you just said, hey, I know that this is 560.
Yeah.
And I just need to take 1 group of 7 away to get 553. Wow. Well, thank you for helping us understand what multiplication is, looking at the bigger groups, huh? Students in grade 3 develop their foundational multiplication reasoning by working through a 1-digit by 1-digit multiplication problem. As we move into 4th grade, students are deepening their understanding by exploring multiplicative comparisons and solving a variety of multiplication problems. When students get into 5th grade, they are now moving into that multiplicative reasoning with decimals and also fractions. When students consistently and intentionally make sense of quantities and their relationships, they build a strong foundation in multiplication, enabling them to tackle larger numbers and more complex problems. So let's continue to explore problem-solving approaches, fostering flexibility and efficiency in our thinking. Thanks for tuning in, and keep doing the math.
There you go. Words of wisdom from Mary Lou right there. Keep doing the math. Well, Emily is here ready to do some math today, right? 4th grade student from Stockdale. You like the number 8. We got you into the Fibonacci sequence there, right? And you are multiplying in 4th grade right now, right? That's some of the math homework you brought with us, right?
Yes.
So head on over to the board. You and Scott are going to do a simple 2-digit multiplication problem right now.
What do you think? What's your favorite 2-digit number?
87.
87, that's a great one to start with. And we need one more.
32.
Okay. Now you got to tell me how you would attack this problem, what you're thinking while you're doing it, and we'll see if we can come up with an answer at the end.
So first, you multiply 2 times 7, which is 14.
Okay, and this 1 that you're putting up here is the extra number, the one in the tens place, right?
Yes.
All right. What else you got?
And then 2 times 8 is 16, but then you have to add the 1, which
Okay.
would be 17.
I like how you put the plus sign up there. It reminds you that you have to add it together. Okay, what about the next line?
And then we're done with this, so you cross it out.
That's probably a good call too.
And then you add a 0 here because you're done with the with the 1 digit. And then
So the 0 takes the place of the 1's place here?
Yes.
Okay, gotcha. All right.
and then 3 times 7 is 21.
So you're putting the 1 down here and then you're putting the 2 kind of up there like you had it
Yeah.
before. Okay, what else?
And then 3 times 8 is 24, and then plus the 2, which would be 26.
Good.
And then you have to add these up.
You're going to add them together at the very end. Okay, I'll make one more color for you.
And then it's 4 plus 0 is 4. 7 plus 1 is 8.
Good.
And then 6 plus 1 is 7. And then 2 plus nothing is 2.
There you go.
Good.
And it
Now,
kind of
no-
follows what you did during the social media problem today, right? 7 times 2 is 14, so this thing better end in a 4, and it
Yes.
does. So that's a good thing you learned today. I like it.
That's what I was going to say.
Yeah.
That's how you can check real quick just to make sure, because there's other ways to check it, but we have other things for you to do. Because did you know that yesterday was the autumnal equinox?
Nope.
Well, now you do know, right? So it was the last day of summer, now we're into autumn. All right? And the equinox is when there is an equal amount of daylight and not daylight. So the amount of daylight, let's say it's 12 hours. What is the amount of non-daylight going to be?
12 hours.
12 hours. Okay, so that's how that works, all right? So the autumnal equinox occurred, right? Everything is equal as far as the time goes, okay? So you are going to work on equivalent fractions right now, and I know you've never done them in your life, but Scott's going to help you out right now with it, all right? So let's just go with 2 over 3.
Okay.
And I'm going to give you guys about a minute. Just kind of talk about how you would approach coming up with an equivalent fraction and what you might even think that means right now, Emily.
So the equinox, you can see, right? There's the root word there.
Equal.
Equal, right? And that's exactly what we're doing here. We have an equal sign. We want to make another fraction that's exactly the same value as 2/3, but doesn't look like 2/3. Okay, so how can we do that? How are we going to make a fraction that is the same value?
So half of, or 2 plus 2 would be 4,
You could do plus, but what were we doing before?
multiplying.
Let's stick with that one because it's kind of a theme, right?
So then
So what could you multiply the 2 by to get a bigger number?
2 times 3,
Okay, so let's multiply times 3. And what's 2 times 3?
6.
6. Now, in order to make this an equivalent fraction, the rule is you have to do the same thing to the bottom.
So 3 times 3.
That's it. And what do you get
equals
there?
9.
So this fraction here is equivalent to this fraction. Let me see if you can do one. Are you ready? What if we have 4/5 and we want to make an equivalent fraction? Now, the number that I want you to use is 4. So multiply times 4 on the top, and what do you get there?
16.
Good. And then you have to multiply it same exact one on the bottom.
And that equals 20.
That's it. You got it. So 4/5 and 16 over 20, those are equivalent fractions. Could you
go.
make another one?
Yes.
Yes, you could. You can get bigger and bigger and bigger, right? You could.
Right, so you can keep on going. You can multiply it by 2, by 3, by 4, by 5, by 6. You can multiply it by anything you want because they're always going to be equal. So you'll remember how to make equivalent fractions because of the equinox now, right?
Yes.
Years from now, you're going to go, oh yeah, I remember equivalent fractions and equinox. Yeah, those 2 old guys told me how to do that thing. We'll be back with more right after this.
To see the northern lights, you need to be in the right place at the right time. Auroras are the results of charged particles and magnetism from the sun, called space weather, dancing with the Earth's magnetic field, and they happen far above the clouds. So you need clear skies, good space weather at your latitude, and the higher, more polar you can be, the better. You need a lot of patience, and some luck is always helpful. A smartphone can also really help confirm whether you saw a little bit of kind of dim aurora because cameras are more sensitive than our eyes. The best months to see aurora statistically are March and September. The best times to be looking are around midnight, but sometimes when the sun is super active, it can happen anytime from sunset to sunrise. You can also increase your chances by learning more about space weather data, and a great place to do that is at the NOAA Space Weather Prediction Center. You can also check out my project, aurorasaurus.org, where we have free alerts that are based on your location, and we offer information about how to interpret the data. And you can also report and tell us if you were able to see aurora or not, and that helps others. One last tip is finding a safe dark sky viewing location with a great view of the northern horizon that's near you.
All right, I know the students over at the STEAM Yard have been very busy with their winches, so we're going to check out right now. What do you got going on, Devin?
4 pencils in. 4. Got it? We go?
Yeah. We gotta wait. All right, would you have a seat on the stools, please?
Oh yeah, sorry.
He'll tell you when to go.
Welcome back here. It is time for our first iteration. Let's start things off with our Green Knights. Again, the goal is to see if we can build a winch using basic materials to lift a bucket with 4 pencils 3 inches off the ground. So, let's start off with the Green Knights. Now, Philly, tell us a little bit about how we've changed our design before this first test.
Okay, so we started off doing 3 of the little ones in the middle and trying to poke a hole through one of these to get that through there with this bit. But that didn't work because this is too hard. So he came up with the idea of doing those 2 and putting the 2 through it for like extra support.
And like taking off that
and then taking this off and putting that on there. And we had to tape it or else it would be too loose and it wouldn't be able to pull it up. And so we tied it, we did this. We have to make sure this is extra structural, has extra structure. And then when you turn it, it'll go up because all the strings wrapped around it.
Okay.
And it just goes like that.
Let's see if we can do this. 40 points on the line. Let's turn that crank and get it 3 inches off the ground. Here we go.
Got it.
We are
3
there.
inches.
40 points on the board for the Green Knights. First points of the season.
Okay, guys.
Let's move over to our Comets. And let's go to Alani here. Tell us a little bit about how things have changed with your design or what's been moving forward.
So our our rod right here was a little bit unstable when we were putting it up, but we sort of fixed it with putting the tape, with puncturing a hole in the tape so it wouldn't move too much anymore.
All right, well, the time is nigh. Let's check it out. Can we get 3 inches off the ground?
Got it.
Nailed it right there. Another 40 on the board. So, both teams thus far successful. Let's check in with the Lightning here. All right. Lightning have been working fervently here. Now, at this point, we've had some display changes. We've had some modifications, even up to this very moment. Now, gentlemen, at this point, we're going to start to do our design here, our test. And right now, it looks like the bucket is off the ground by a couple of inches, so it's going to be 3 inches from where it is right now. So let's measure to see how far off the ground it is at the moment.
We have just over 3 inches.
So we're going to try to get it 6 inches total off the ground. Let's go ahead and test out to see what we can do.
Other way. Oh yeah, no.
Got it.
Nailed it! 3 inches off the ground from the additional 6. So now the Lightning, at the last second, able to pick up those 40 points. Let's move on over now to the Sharks. And Sharks, you've been building a design off the edge of the table as well the entire time. Tell us a little bit about how your design has changed. Let's go advance here.
So we were trying to get this to rotate so the string can go around it so it could lift the bucket up. And the problem was that it was too loose, so we had to add tape in the middle to make it to where there's enough room for it to actually spin. And then we tried it and it worked a few times.
Now this is another instance where the bucket is off the ground already. So let's figure out how far off the ground it is before we see if we can bring it up 3 inches.
You got about 1 inch off the ground.
So if we can bring it up to 4 inches off the ground total, we'll have 40 points on the board for the Sharks. Let's see what we can do.
Got it.
Nailed it with ease. So, all 4 of our teams were successful in this first iteration. Now, coming up after the break, we have one more challenge. If you could, let's talk a little bit about this bonus round where teams can earn many, many more points.
So we want you guys to add more pencils. So we're going to add more mass to your buckets, and let's see if you can also bring it up 3 inches.
So we're looking, and we're going to have a cap on that, as many as 10 points per pencil, up to 10 pencils. So teams can earn up to 100 points if they're able. But you have to guess how many pencils you're going to lift before we actually try it out. So talk that through, test out, see what you can pull off. Let's check out the leaderboard and see where we stand. Again, all 4 of our teams meeting the goal, and all 40 teams getting 40 points at the end of our first trial. When we come back, we'll see how many teams can pick up those big bonuses as we wrap things up here on day 1 of the Steam Yard Showdown.
All right, those guys are well on their way, and I think we would just go and put all 10 pencils in, right?
Yeah.
Yeah, we're not messing around going 7 or 8 or something like that. Somebody else might, we want to win this thing, right?
Yep.
Just be confident in what you've already gotten. You know what? Throw 20 in there if you want.
Yeah.
Sound good?
Yep.
All right. So you, young lady, we are doing a lot of multiplying today. So there's a new program that we're using on Do the Math this year called Struggly, and it is to help you struggle with math problems. Because every time you struggle, your brain actually grows and you learn more from that struggle. So are you ready to struggle?
Yep.
Good. Head on over to the board. Because with Struggly, there are no directions. You are just going to have to figure out how this works and how to advance and check and see if everything is correct. So you and Scott, go to it.
Emily, what do you want to do? What do you think?
Put numbers in all the boxes.
All right, you want to draw on there with your finger? See what happens.
Can I use this?
I think you can, but you can probably just maybe use your fingers. Maybe not. Maybe.
Well, the problem says 2 times 4, right?
Oh, what about here? What does that say?
Oh, 2 times 4.
Yeah.
What's that?
I don't know. Touch it and see what happens. Aha! Now you got a little board there. What is 2 times 4? What's 2 times 4? Just got to work out that problem first.
2 times 4 is 8.
Okay. Hit the 8, see what happens.
Wow.
Ah, look at that. Okay. So we got that part. Oh, look at that. Interesting. All right. See what happens with that one. Yeah, go on the next one.
Maybe you can.
Oh.
What's that do? Whoa!
Uh-oh. Look at that. That's kind of crazy. So now you have an idea of what we're doing here, huh?
Yeah.
All right, how do you go to the next one? Start touching stuff, see what happens. Ah, can we do another one? Okay.
Yes.
Whoa, where are you going to put that one? Right underneath it? Okay.
So when you turn that arrow, right.
Oh, this flipped it over for you, right?
Right, different orientation.
Oh, nice. Okay. Oh, I finally gave you a different problem now.
Whoa.
Whoa. So what do you think the point is of this thing?
To fill out all the boxes.
Yeah, let's fill in some more boxes. What's 2 times 3?
6.
Okay, you got that part. And where are you going to put that one?
I'm gonna put this.
Oh, so now you got an idea where you're going to go and do exploding it a lot more quickly now. All right, 3 times 4. That's a pretty big one. I wonder if we have an idea of how big that's going to be.
12.
You got the 12 part for sure. And then, oh, interesting. They did it there. Whoa, well done. Do you have an idea about which part you want to get done next? You want to do the bottom or the top? What do you think?
The top.
Oh, and you did the twisty part, right? Oh, there you go. You got part of it for sure.
It's like you mind some track. Oh.
Uh-oh.
We're trying to find a picture.
And what do you think that picture is?
Oh, wait.
Any idea? That's a really goofy looking picture if you ask me.
I have no idea.
I have no idea either. We're going to find out hopefully. Okay, 16. This should be a bigger one, right? In theory. Yeah, what if you do that one? I like that. And then you have a little piece over here.
I found a mouse.
You got a mouse. What the heck?
We're supposed to find a mouse.
Oh, so maybe that was the whole point, right? So maybe we didn't have to go, once you had this little piece over here, you didn't have to keep going in that area. You could have gone all the way around the picture,
Yeah.
right? Just because you're looking for How many mice are in this one?
2.
There's 2 of them. Okay. Getting the hang of it.
There you go. So keep going. We'll give you another minute, see if you can find the 2 mice.
Not there. Where are you going to put this one? Oh, she's going faster now. I like it.
Right.
So now where are you going to put that one? Anywhere else, huh? Not there. Remember at the beginning we had no clue what this was all about, and now we have a lot better idea what's happening. Uh-oh. Getting close. Doing the math pretty quickly. Well, it looks like you probably opened one of them. Oh, so close.
Okay,
What is
you've
that
got
little
about
red one?
45
Get that
seconds
red one.
left. See if you can get those mice.
Whoa.
Oh. All right, so where are you going to put that one? Okay, definitely want to uncover that one. Okay, you got one of them. Where are you going to go next?
30 seconds.
Oh, it's a time crunch now. Get over there somewhere. Where might it go? Oh, I don't see a mouse yet.
Oh, will she find the other mouse?
This should be a big one. Yeah, that's a good idea. Go way up there. Oh, so close. Keep going.
10 seconds. See if you can get part of the mouse on the last one.
No pressure, but a little bit of pressure. Oh, where? That's a good choice.
That looks like a good spot. But anyway, you get the idea of struggling now, right? So there were no directions, and you figured it out on your own, right? And then you figured out, oh, I got to figure out how many mice I can find, right? So something that you can play, there's a lot of different things you can do right there. So struggling, a lot of fun for all different kids. We'll be back with more right after this.
In every type of work, it doesn't matter whether you're a physician or a physician assistant, if you're a student or a professor, if you are a truck driver or you're an automobile designer, it doesn't matter what your type of work is. You can always find those things where AI tools can be very helpful to you to enhance your capabilities and abilities. And so if you take health, there are aspects of health that can benefit from using AI in all the way from understanding the genome to delivering patient care, right? It could be in learning. A student now can find that they can do anything in terms of advancing their learning aspirations by being able to find what are those specific things that you find that you don't understand well. So essentially it becomes like your partner, if you may. Like you and the machine, in this case AI, are working together in terms of being able to expand your capabilities, your effectiveness in whatever field it is in, the ability to be able to learn from the data, to be able to predict, to be able to help make decisions. Because it's like asking the question, what can a human be useful for? The question is no different. Once you have a person who is capable of doing something, then you say that this person can do these things. So you take any task, whether it is a driving task, whether it is a task that is based on predicting the weather, or whether it is a task based on how do I learn what I need to learn which I don't know anything about. You take any task for that matter, you can always find a way that AI can be useful in that context. Because at the end of the day, it is all about data, learning from the data, building models, and then using those models, then being able to predict based on what is not known yet. So these are the kinds of things that you do in every aspect of your life. I mean, look at your everyday activity, right from the time that you wake up until you go to sleep. Every activity that you encounter is based on some kind of a recognition pattern, as some kind of a decision that you make, or some kind of a learning that you have that helps you for the future. So all of these things are what we do as humans, and therefore AI can do similar things in any field that you can think about. You can imagine that being part of everything. It's like a fabric almost. Every thread of that will be AI enabled, right? So that's what you see the future is going to be filled with AI being part of everything and anything that you do. We won't be talking about AI as something as separate. It will be so much a part and parcel of what we do. It will become like we don't talk about electricity as something like a separate thing. It has become part of our fabric. That co-evolution of technology and human will evolve into a future where the AI components are empowering, enriching, unleashing new possibilities from the human side, and the human is then making possible the AI to learn all the things the human does. And so what AI presents to us, the opportunity to be able to unleash all of the human potential for the benefit of humanity and beyond. Imagine every area, rural area, every urban area, all the 50 states and territories of our country, and people everywhere being empowered, energized to be able to exercise their talent to the fullest without any holding back, without any constraints. Imagine that.
Well, we have Emily, a fourth grade student, working on multiplication all day, and she is still struggling with struggling and having fun with it. She doesn't even want to stop, so we're going to let her keep on struggling over there with the multiplication. But we do have one last opportunity to go check in with Devin and Jamie and see what the kids are doing at the STEAM yard.
Pretty close.
Come on.
And welcome back, wrapping it up with the final test here at round 1 of the STEAM Yard Showdown. As we left you last time, all of our teams were able to successfully build a winch that was able to lift a bucket with 4 pencils 3 inches off the ground. Now, we've upped the rigor and we've upped the stakes. Teams have been asked to predict how many pencils they can load into those buckets and still be able to lift them 3 inches off the ground with their winches. For each pencil, they'll get 10 points. Now, if it fails, they don't get any points. So, big predictions with big stakes at the line. Let's start off with the Knights here. Now, Trevor, how many points or how many pencils are we predicting that we're going to be able to lift here?
10.
10 points. So we could possibly get 100 points on top of the 40 you earned after the first trial. Did we make any changes to help with getting us up to 10 pencils?
No, not really. Just adding more stability.
Okay, well let's go ahead and crank it up and see how we do here.
Got it.
With ease, 10 pencils, that's 100 points. To earn the max for the day at 140. Now, let's visit over with the comments. Jay, tell us a little bit about how many pencils your team is predicting.
I say that I think we're gonna have 10 pencils.
Now, not just 10, but style points wise, I don't think we could offer any more than what we've got for as far as how well they predicted 10 here. Now, that means you had a lot of time to draw that out and a lot of time to test things out. You were testing out 10 pencils very early on after your build. Was there anything that you felt like you had to change in order to guarantee that we can make 10?
Not really.
Well, we added more tape, just so it's more like stable.
So more tape to make the base a bit more stable. Let's test it out and see if we can get 10 pencils, 3 inches off the ground.
Here we go, 3.
Another 100 points on the board. The Comets and the Knights are neck and neck. All right, let's come on over to the Lightning. Lightning has been working through nonstop, even to the point of testing. How many pencils are you predicting?
10.
Now, I'm going to kind of reveal something in terms of the conversation early on. 10 was not your it's not your initial prediction. If we could, they were going to predict 9. What made you change your minds and try to go up to 10?
So we could get more points.
Well, yes, the more points, but was there anything that told you that your design was ready for 10 pencils, Bilal?
It looked like it was ready for 10 pencils because it looks like all we have to do is add more back weight.
And you added a lot of back weight and a lot more tape to this build to be ready for that. So as long as there was more balanced on the back end, you felt you were able to pick it up a little bit more. So again, our pencil bucket is already off the ground a little bit.
We're at about 2.5.
So we're going to get to 5.5 inches, and that will get you to the 10 pencils and 100 points. Let's try it out. Slowly, can we get there?
About a 1/2 inch.
Almost.
Getting closer.
Suspense.
Got it.
Phenomenal. I hope you felt the exhale, the relief of the Lightning to get right back up there. They'll leave with 100 points on top of the 40 with another 140. Now let's visit with the Sharks. Elena, very confident, a stable build. What was your team's prediction?
My team's prediction was we were gonna get 10
pencils.
Another 10. So was there anything that we needed to do with the design to get you confident that you could pull off those 10 pencils in the lift on the bucket?
We just put a little bit more tape.
Where did you put the tape?
Somewhere here.
Mostly along the top end so that we don't have anything spilling over or it doesn't kind of balance out or weight down as we bring that spool up. So again, our bucket is already off the ground. Let's just check to make sure how far off it is already.
We are on the ground.
Oh, it's already there. Great. Let's go ahead and see if we can get 3 up.
Got it.
Nailed it. Another 100 points on the board. All 4 of our teams were able to hit the maximum, 10 pencils, 100 points each. Now, if you're interested at home in trying the Steam Yard Showdown for yourself, please make sure you visit our social media outlets and our channels. All the materials that were used and the constraints are there for you to try it out, see if you could get the max points yourself. Looking at our final tally at the end of our first challenge, all 4 teams were able to successfully complete every one of the challenges with the maximum points. We have a 4-way tie at 140 points each. All of these points carry over into our next round. The next time we see you, it's higher stakes and greater challenges. And we hope to see you back here next time at the Steam Yard Showdown.
All right, kids had a lot of fun out there, and I know you were kind of going along too, right? Because the 10 that you would have done probably would have worked also, right? Mm-hmm. So in the meantime, you were struggling, right? Because you're doing a lot of multiplying in 4th grade. You're doing a lot of multiplying today. And you were able to mine while you were multiplying, right?
Yes.
And how did you like that game?
I liked it because it was all about like finding stuff and you can do math while doing it.
Right, so you had a little bit of fun doing it, right?
Yes.
But did you struggle a little bit at the beginning of it?
Yes.
That's the whole key right there, right? That's why it's called struggly, right? Because they don't give you any directions. They just want to see if you can figure it out on your own, right? And you have to like kind of like hit different things to see, you know, what will actually work and stuff like that, right? Mm-hmm. So if you could do this along with your math course in school, do you think you would like to do this during school?
Yes.
All right, good. Well, you know what? We'll see what we can get going, and who knows? Maybe you can be on Do the Math again sometime, because we're always doing struggling in here. Sound good?
Yes.
All right. Did you know that you are now an ambassador for Do the Math?
No.
So you have to tell people about Do the Math. Can you do that?
Yes.
Just like today when Nikki came in, was talking to us about quilting today, because we went out to the Kern County Fair. I saw the quilting thing and I was like, hey, we have to have somebody from there on talk about quilting and the mathematics behind it. So I'm telling people about her quilting project that is going on at the Kern County Fair. You can find out more over in Building 4 at the Kern County Fair. Just like you will be able to tell people about Do the Math.
Yes.
You can do that?
Yes.
Excellent. Well, one of the things you'll be receiving is this Rubik's Cube. Are you a master of this?
No.
Nor am I. I know how to mix it up a little bit, but they said that I mixed this up, but it looks mixed up like in a pretty good pattern, doesn't it?
Yes.
It doesn't look totally messed up. You're kind of like, oh, it's a pretty good pattern right there.
Yes.
All right. So I know that you like nature also and science, okay? So I know that you're getting pretty excited about watching all that science. I want you to do one thing for me. Sometime between now and the end of the school year, I want you to look up the Fibonacci sequence in nature, okay? Because you're going to be able to find things with the Fibonacci numbers. Remember 1, 1, 2, 3, 5, 8, 13, 21, right? So we'll show you how to spell the guy's name, and then you can look it up, all right? You're going to see that Fibonacci sequence in nature a lot of different places. So that's going to be something that you can check out, all right? In shells, sunflowers, different types of animals, plants, and things like that. Sound good?
Yes.
All right, good. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union. with additional production assistance provided by these supporters of education.